Hello, now we are going to explain the application of differentiation. We are from class P2PH1102B1. Firstly, we are going to introduce each of our members. I am Nur Shakina.
Hi, I am Radiatul Adha.
I am Shalina Edelweiss.
I am Nur Ilani.
Firstly, the introduction. Problems with related rates require two or more variables that change simultaneously, possibly at various rates. Knowing the relationship between the variables and how quickly one of them is changing will allow us to calculate how quickly the other variable is changing.
This is the basic steps for solving problem using differentiation. Number 1. Draw a diagram if possible. Number 2. Label the quantities. Number 3. Find an equation that relates the quantity whose rates of change is to be found to the quantities whose rates of change are known. Number 4. Use the chain rules or implicit to differentiate both sides of the equation with respect to time. Number 5. Solve the derivative that will give the unknown rate of change.
So, what is differentiation? Differentiation is a method of finding the derivative of function. When do we apply the differentiation? First, to calculate acceleration. We calculate the rate of change of velocity with respect to time. The second one, to calculate the highest and lowest point of the curve in a graph or to know its turning point, the derivative function is used. The last one, to find tangent and normal to a curve.
Furthermore, other applications of differentiation are analysis of functions 1, increase, decrease, and concavity, analysis of functions 2, relative extrema, first and second derivative tests, applied maximum and minimum problems, and lastly, Rolle's theorem and mean value theorem for differentiation.
A conical water tank with vertex down has a radius of 12 meter at the top and is 26 meter high. If water flows out the tank at the rate of 22 meters cubed per minute, how fast is the depth of the water decreasing when the water is 18 meter deep?
Next is the objective on how we need to calculate this problem. First, we need to draw a diagram of a converted cone and then label the quantities as given in the question. Thirdly, find an equation related to the question. For this question, we use dH over dt equals to dH over dv times dv over dt. And then we need to use the chain rules. Finally, we can solve the derivative to find the rates of change.
Firstly, we are required to take out all of the information given in the question. Then, in this question, we are required to state the rate of water decreasing when water is 18 meter deep. The first step we need to take is that we need to write out the chain rule, which is dH over dt equals to dH over dv times dv over dt. We also can get to the solution by using the formula of Kuhn. We need to use the Kuhn formula in order to get the R value. So, change the formula so that the V is in term of R. After that, substitute the value of R into the Kuhn formula and we get 12 over 169 by H cubed. After that, we need to search for dH over dt by using the previous method. Finally, substitute the value of 18 inside dH over dt that we already get to get the answer of negative 0.1015 liter per minute. In order to check for the answer, we can use the second method, which is the implicit method. This is a simple step, yet we still able to get the same answer. Students can use any of the three methods that they prefer during the exam. As you can see, we still maintain to able to get the answer of negative 0.1015 liter per minute.
Problem statement number 2.
A conical water tank with vertex down has a radius of 10 meter at the top and is 22 meter high. If water flows in the tank at the rate of 18 meter cube per minute, how fast is the depth of the water increasing when the water is 20 meters deep? Next is the solution. First, we need to take out the information given in the question. The question requires us to state the rate of water increasing when water is 20 meters deep. The first step that we need to do is to write out the chain rule. After that, we need to use the cone formula in order to get the R value. So, by changing the formula so that V is in terms of H, we can get the R value, where the R value is equal to 1/2H. After that, we substitute the value of R into the cone formula, and then we would get 1/12 pi H cubed. Next, we find the derivation of dH over dV, which is equal to 4 over pi H squared. Finally, by substituting the values into the chain rule, we will get the answer, which is equal to 0.057 meter per minute. Besides chain rule, we can also find the answer by using implicit differentiation. The first step that we need to do is to write down the implicit differentiation formula. After that, with the formula of cone, we need to find the R value, where R is equal to 1/2H. So after that, we substitute the value of R into the cone formula, and then we got 1/12 pi H cubed. Then we substitute the values into the formula of implicit differentiation. Then we would get the answer 0.057 meter per minute. Conclusion: by using formula of chain rule and formula of cone, it is found that we can determine the rate of water flows out, decreasing. With the information given, we need to substitute